Hi, everyone. So today, as we review stars before your assessment, there's a couple of things I want to keep in mind. Okay, so just stars in general. We're going to focus today on the color, how that indicates the temperature of any star, how scientists identify what they're made up of, how scientists classify stars. So please follow along. So when we look here at this lovely picture, one observation you should be able to make as a scientist is that stars come in different colors and sizes and their brightness, or in the star world, we call that luminosity, which is how they shine, luminosity. So the brightness of a star depends on two things. This is very important to keep in our head as we progress here in the solar system. Depends on the distance from Earth and the amount of energy the star gives off. So when we talk about the color of stars, they tell you how hot a star is. So here's one of the most popular stars. Looks like Betelgeuse. It's pronounced Betelgeuse. Look at that. It's very, very bright. You should be able to see that far in the distance. Look at that color. And here's another popular, very hot star, pronounced Rigel, and that is found in the constellation Orion. In the star world, blue-colored stars burn much hotter than yellow stars, like our sun. So here's showing you some popular stars. Look how bright they both are shining, and they're a different color. Better picture from a distance, Rigel, very blue-white. Betelgeuse looks red, some orange. So pay attention here to this diagram. So they're classified by their temperature. So here we have this would be a small hot star because it's blue. Here's the sun, medium size. We'd say in the star world, warm, not hot, not cold. Here would be a large star, but cool because it's reddish orange. So blue typically is above 30,000 degrees Celsius. That's Rigel in the previous slide. Blue-white is extremely hot too, 7,500 to 30,000 degrees Celsius. Yellow-white, 6,000 to 7,500. Yellow, like our sun, 5,000 to 6,000. Let you guys kind of pause it and pay attention to that table yourself. So stars we know vary in color, and the color of a star is directly related to the temperature of that star. So the hottest stars are blue and the cooler stars are red. So here again, if you want to pause the video, focus on the color, the surface temperature, and colors and relative size of the stars. So here's a diagram of very popular stars in our solar system. We've got the sun, yellow. Look at that size compared to a very popular star pronounced Sirius, larger than the sun. Blue, so that equals hot. Another popular star pronounced Pollux, getting bigger, but not so hot because it's orangish tint. Bigger star. Then over here, popular one, Betelgeuse, red and big, but cooler temperature because it's red. So this is a nice diagram. If you want to pause the video, really focus on the color of these popular stars, the size, and remember indicating. Out of this diagram, we should be able to analyze the sun is the smallest star. The largest star is Antares. The hottest star is Sirius, based off this diagram because it's blue, and Rigel. The coldest star out of all the stars listed is Betelgeuse because it's the reddest. The star similar in temperature to Pollux, I'd say, is Aldebaran. So over here, comparing pretty close in temperature. So again, you can pause the video and analyze this table deeper. So I want you guys to think about, you have 5 stars in front of you. And if you were to shuffle them up, they're out of order.